Right. Huh? I know you did them, but you were complaining that I made you do them and not answer those or put those questions in, right? Huh?
It is very great. It's a Greek one.
All right, so I'm going to
Are you going to taste one?
look at that
No, you spell
and look at that. Okay, those are parallel lines, right?
it. Yeah.
My hopes are is that you realize that it's kind of pointless to look at those two parallel lines, right? Because those two parallel lines do not have a common transversal. All right, so we're going to look at these two. Okay, and I'm going to draw in or highlight
Did you make that line straight so that way you can like set it equal to 180?
that transversal. Okay, so when I remove things, okay, 4x minus 2y, that angle there, and that 70, if I remove the picture, what types of angles are they for your parallel lines and transversal?
Same side. Alternate.
No, they're same side.
Yeah.
Same side of the transversal is the green line, so it's the same side of that, right?
Yeah.
But where are they in comparison to the yellow?
Vertical.
Interior. Okay,
Inside.
so they're same side interior.
The yellow?
Huh? They're on the same side of the green line. They're both on the left of the green line, and they're both on the inside of the two yellows.
I would get confused because I think inside of the green line.
Well, how would you be inside of the green one?
That's what I was confused.
Okay.
Mr. Fay.
Yes.
So like what I thought was
Oh.
4x minus 2y equals 110, and like I did like the substitution thing where like y would equal that.
Yeah.
And I plugged it in, and
Yeah.
then like just like cancel out, and then it'll be like 110 equals 55.
Okay, so when we do that, and I'll use that approach, but when we do that, they should end up giving us, should leave us with at least a variable. So there's probably somewhere in your algebra that you're missing a sign, okay? And then we'll talk about how we can do this. So you're saying, so what he's saying, guys, is that if that's 70 and that angle is 4x minus 2y, is that those things have to be supplementary, right? They're same side interior. That's what you told me. And he's just going right away and saying, well, if I know that this one's 70, these two have to be supplementary, I automatically know 4x minus 2y has to be 110 degrees. Is that okay?
Yeah.
All right. So then we do the same type of thing down here with that line, they are parallel, and we look at that transversal. Again, 4x plus 2y and 50 need to be supplementary. So we're seeing that 4x plus 2y should equal 130, correct? Okay. So now, and I'm going to go through this two ways. I'll do this the way it's kind of set up, I think, to answer this quickly. But there are multiple approaches to the algebra here. But because those both have two variables in them, and I've stacked those variables, x's on top of x's, y's on y's, and constants on constants, I'm going to add straight down. And how many x's do you end up with?
8.
8x. What happens to these y's?
They cancel out.
They cancel out, okay? So they're gone. And then if I add my constants together, I get
240.
240. So now x goes into 240 30 times, okay? So now if x is 30, I should be able to take one of these original equations, maybe 4x minus 2y is equal to 110. I should be able to plug that 30 in and solve for y. So if I plug in 30 to right there, it gives me 120 minus 2y equals 110. Subtract 120 from both sides, so negative 2y is equal to 10, negative 10. So y would be
5.
5.
Positive.
So x is 30, y is 5. And now, here's the thing. I'm not confident whether all that algebra was right, okay? I am 100% confident that our geometry is right, correct? Okay, and hopefully that's where we get to the point where, yeah, we can set the geometry up, we don't have a problem doing that. It's then whether the algebra was right. Well, the way I can gain information, gain that understanding of whether my algebra was right is plug those values back in, okay? What's 4 times 30 right here? 120 minus 2 times y, minus 2 times y would be 10, right? So I get 110. We initially thought these two angles should be supplementary, right?
Yeah.
Are they?
Yeah.
Yeah, so I just checked and proved to myself algebraically that everything I've done so far with this algebra was accurate. I didn't make any mistakes algebraically. Does that make sense?
Yeah.
If I would have gone through here, it maybe got y to be negative 5. Maybe I messed up my division. okay? And I put negative 5 in there, so this would have been positive 10, okay? So it gives me 130 there, and that would give me 70 plus 130 is 200, not the 180 that I thought I should have, right? So because I plugged back in, it tells me something in my algebra was wrong. I want to go back through my algebra and reevaluate, kind of pan through it and make sure I can see where I might have made my mistake. My suggestion is when you plug back in, especially on tests and quizzes, don't just erase everything right away. Because if I start all over from scratch, I'm going to have to do a lot of the similar work that I've already done, especially with my geometries, right? If I can go back through my work that I've laid out and I've organized, I might be able to recognize where maybe like in the previous example where we added 26 or subtracted 26 from both sides, and added 26 from both sides. That makes sense? You can find that simple minor mistake, fix it real quick, and get on to the next problem, where you're not sitting on a problem, doing it 3-4 times, wasting a lot of time on each time you do that. Okay. So now what you were saying is that there are other approaches. There is an approach here where I can use that. We use just that process is called elimination. I think that's the way this is set up. That's kind of the best way to do this problem. But there's nothing wrong with saying if I have 4x minus 2y is 110. Can I take that equation and say that 4x is equal to 110 plus 2y? Does that make sense? And I could go further. I can divide everything by 4 and solve for an individual value of x, okay, a 1x. But I recognize that if I do that, and I also have this second equation right here, 4x plus 2y equals 130, okay, is there a 4x over here?
Yeah.
So what can I replace that with?
Oh, that equation right there.
I can replace it with this stuff over here, can't I? Okay, we're saying 4x is that same thing. So I got 110 plus 2y getting to replace that 4x. This 2y stays.
Equals 130.
Equals 130. So now I got 4y equals, move that over, be 20, right? So what's y going to be? 5. Is that the same 5 that we found using elimination? Yeah. And now that I know what y is, can I come up here and say, okay, I got 4x is equal to 110 plus 10. So 4x is equal to 120. X ends up being 30.
Mm-hmm.
Okay, so we can use substitution in that manner, okay, to solve that system. We can do it a different way. Because, you know, in this equation, could I have solved for 2y? Or 1y and plugged into the other equations, okay? My thought is just be careful here. Let's say we start with... let's write the bottom one, 4x plus 2y is equal to 130, and this might have been kind of where maybe you would have ran into an issue. If I solve this one for 2y, because I see there's a 2y in that one, right? So I'm going to solve this blue one for 2y. So I get something like that, okay? Now I'm going to take that 2y, which is 130 minus 4x. I'm going to replace that 2y with it, okay? So it becomes 4x. We're writing this equation here, 4x. Minus now I'm taking that 2y, it was minus 2y, and now it was one singular object, we call a monomial, okay? And I'm replacing it with two objects, a binomial, makes sense? And what I want to do is I want to make sure that I understand that I'm going to, in the original equation, 4x minus 2y, I subtracted 2y. Well, now I've got to subtract this, because they were equal, right? So I'm subtracting two things. So I need to make sure that I realize I'm subtracting the 130 and I'm subtracting the negative 4x. If you don't do that, you're going to run into some issues. Okay? But what's going on here now, so it's going to replace with a quantity. I got to make sure I put parentheses around it, because what's that tell me to do with that negative? Yeah, but
Put it in the parentheses. Oh, there should be.
I got to distribute that, because it's really a negative 1 times that stuff. So I want to remove the 130, remove a negative 4x, so minus a negative 4x becomes positive 4x.
Plus 4x.
Okay, so it gives me 8x, be 240, okay, and then x will be 30. Where if you didn't do that, and that's the 30 we found out using elimination, right? So we know that's the right answer. If I didn't do that subtraction, I'd have 4x minus 130 minus 4x is equal to 110, and now we see the 4x's would actually cancel out. Negative 130 equals 110. That's a false statement, and hopefully we realize that that doesn't really make a whole lot of sense for this particular problem, right? There are times where maybe that would happen if we write the correct equation and do the correct algebra, that we do sometimes get false statements and true statements. And we'll talk about what happens when we get those. But in this case, we're getting that false statement because of an inaccurate operation. Okay, so just be careful that there's other ways you can substitute. Kind of the whole task here, the whole thing of doing this a couple different ways is that we see that we eliminated or did that problem with elimination, and we solved for, I think when we solved for x first, we could have eliminated the y's and solved for y, or eliminated the x's and solved for y first. Okay, so there's two main routes that you could have gone there. Substitution has 3 or 4, maybe 5 different routes you could go. Okay, so what you do on your paper might be different than what your neighbor does on their paper, which might be different than their neighbor does on their paper. But you all three arrive at the same solution. Does that make sense? And that's kind of that's the nice thing about geometry, because if you can't see it one way, maybe you see it better a different way. But it's also kind of a problem, because when you ask me in class, how do I do this? I'm going to give you multiple ways, and you just got to pick the one that makes most sense to you. Okay? So just keep that kind of stuff in mind. Carter.
So,
Let's go look at the math homework.
are you going to change those minus one?
Yes, I will change it. Yes, you'll lose more points.
How?
Huh? Because I'm going to change them.
Oh, stupid. No, change them right. If they were right, I just mixed them up.
Well, then they were wrong.
No, but they were.
That doesn't make sense.
They were right.
If they were right, then it would have said they were right, right?
It did say they were right. They were
No, it said they were wrong.
I don't know that.
You just told me. Carter. I will change it for you. I hate it. All right, so I'm going to do this one. This kind of maybe is a problem that allows you to see a particular application of parallel lines, where we're going to see it and use it later on. Because I bring in a new idea here that we haven't really discussed in class, but if you can read this and maybe you realize from previous courses, hopefully you've learned this in maybe 7th and 8th grade. If I take those 3 angles of that triangle and add them together, what should they always add up to?
180.
180, okay? And what's really nice is that we actually get the same results by taking those 3, okay? And add them up and getting 180. Because there's parallel lines here, what actually happens is that we get that triangle right there and that triangle right there
We did this last year.
to become what we call similar triangles, okay? And what we learned about one of them helps us learn everything else about the other one, okay? So, we're going to walk through how we would do this problem. The first thing it walks you through and tells you to find x, right? So when we look at that transversal, look at that parallel line and that parallel line, what would you tell me about that angle there and that angle there?
They're congruent.
They're congruent. Why?
Because alternate interior angles.
No.
Alternate outerior angles.
No.
Oh, same side.
They are same side, but they're one's on the inside, one's on the outside. Right?
Yeah,
So they correspond, right? Okay. So those are corresponding. Okay. And corresponding are congruent, so their measurements are equal. So we get x to be
68. Y to be
34. We're going to divide by 2. Okay. So now if x is 34, I'm going to go through and I'm going to find what that measurement right there is. 3 times 34 is 102. Minus 15 is
92.
87.
87. How's close? How's close?
So we got 87. I've got an angle here of 68. And I've also got this angle here of y squared, right?
Yeah.
Now, like I said, you can use either of these triangles. You can use the big triangle, or you can use this small triangle, because that's going to be 87 as well, right?
Wait, just add up 87 and 68 and subtract it from 180.
Okay, so you're saying that because of the triangle, the 3 angles we had were y squared, 68, and 87, right?
Yeah.
Add those together, they should total 180. So there's the geometry. Now it's all about, do I remember Algebra 1 information, in which I've got y squared, this becomes 155, this becomes 180.
Subtract it, you get 30.
And y squared Subtract the 155, you get 25. Okay?
But y equals 5.
Okay, well, why does y equal 5? What do you do next?
Because if you substitute 5 for y, 5 times 5 is 25.
Okay, so you're going to do it that way. That's fine. Okay?
I don't know, because I don't know how to do it the other way.
Okay, well, if we got power 2 here, okay, and there's no other variable. That's the only variable you have, y squared. There's no y to the first, okay? You can do the square root method, which just means I take the square root of this side, and I'll take the square root of that side, okay? So that gives me y, square root, and the power of 2 are inverses. Kind of like multiplication and division are inverses. They undo each other. Addition, subtraction undo each other. Square roots and powers of 2 undo each other, okay? So if I have like 5, and I square it, I get 25, right? We'll take the square root of 25 and get you back to the 5 that you started with. That make sense? Okay? They're inverse operations. So, this is going to give me 5. Now, here's the thing. Remember what this really means here. That is a symbol for another number. Radical 25 is a symbol for another number. And that other number is some number that I multiplied by itself 2 times to get the 25. So what numbers do that? 5 and negative 5. 5 times 5 gives me 25, but negative 5 times negative 5 also gives me this 25. So what we want to do is realize that there's a plus or minus. There's 2 solutions, positive 5 and negative 5, that will work for this. Okay. Now, here's what's going on. So that's the value of y. That's what this algebra is showing us. Okay. And this is something that we want to think about as we go through all these problems throughout the year. When I factor and I find multiple solutions, okay, my algebra, okay, all the algebra I did right here, this math, okay, and the way it relates with one another does not know that that represented an angle, that represented an angle, and that represented an angle. Does that make sense? Okay, the algebra doesn't know that it came from a picture, okay, and that it has other requirements, other constraints on it. So what we need to do is we need to come back up to our picture and say, okay, we had y to be 5 and y to be negative 5. We need to make sure that when we plug those answers back in, we get an angle that we're allowed to use. Okay, we get a measurement that we think makes sense to us. Okay, if I plug 5 in, 4y squared, you get 25, right? Is 25 an okay value for an angle measurement? Yeah, it's between 0 and 180, correct? Okay. If I plug negative 5 in, is negative 5 squared, what's that give me?
25.
25. Is 25, again, another angle that we're allowed to have? Yeah. So that tells me both these things are solutions. Okay? A place that we might, maybe see where this could, why I would have to do is maybe at some point I do some algebra and I get like y to be 5 and y to be 10. Okay, y to be 5 and y to be 10. If y was 5, that'd be okay, because I get 25. Okay? But if I get y to be 10, plug 10 in here, what do you get?
20.
I get 100, don't I?
Oh, yeah, I was thinking.
10 squared is 100?
Yeah.
But now here, think about why that 10 would not work. If that's 68, and that's 87, and that's 100, do all 3 of those angles have to be bigger than 180 degrees?
Yeah.
So what we have to do is we have to kick out the answer of 10. It doesn't work because it blows up that picture. It violates predetermined constraints that the rest of the geometry kind of already set up for.
Couldn't you just plug in a random number in?
Huh?
Couldn't you just plug in like 2 or something? Because it stays under 180.
No, because it has to be equal to 180.
Oh, yeah.
All right, so that's why we had to check this. Now, there's other ways of doing that. We saw, we walked through and got y squared is equal to 25. Does everybody agree or understand how we got that? Okay, just by that simple moving of the 155 to both sides. There's another way of coming up with our solution here, and it's looking at it this way. Y squared minus 25 is equal to 0. Okay, my hopes are that, yes, this makes sense here looking at it this way, but I also want you to be able to view it this way and make sense of it that way, because that becomes an alternative route that becomes very important later on in your algebra. If I look at these 2 things, okay, what kind of number is 25? What kind of number is that? It's a special number. Because it was 5 squared, right? Gave me 25. So what types of numbers, when I take the square root, I get a whole number back? What kind of number are those?
Square root numbers.
No?
Oh, they're,
Perfect square.
Perfect squares. Okay, so 25 is a perfect square. Now, look at y squared. Y squared is a number as well. But I don't know what it is. But let's say that y was 8. What would y squared be?
64.
64. Let's say y was 9. What would y squared be?
81.
81. Let's say y was 11. What would...
101.
Let's say y was 15. What would it be?
Oh, man, I got 61.
225.
225.
So,
Okay? So, what type of number is y squared always going to be? What were those numbers? 81, 64, 100.
Square roots.
Whole number.
They're whole numbers, but weren't they numbers like this one here?
Yeah,
Weren't they perfect squares?
yeah, that's what I meant. What?
So you got two perfect squares there, right? What operation are you doing between them?
Multiplying.
No.
Dividing.
What is that right there?
Subtracting.
Subtraction. Okay. What's another word for subtraction?
Minusing.
Okay. What's another word other than that?
Taking away, getting rid of.
Starts with a D.
Deciding.
Say again? Nope, not division.
Dedication.
If I say here are two numbers, 9 and 3, and you subtract those, you get 6, right?
Oh,
6 is referred to as the difference.
oh.
Okay. So when I subtract, you guys remember back to Algebra 1 for a couple of weeks, you got those English phrases, and it would say, write out in algebra the difference between x and 12. Okay. So you want x minus 12. Okay. This is a difference. Okay. When we subtract, we're doing a difference. But what kind of number was that?
Why?
Square root.
What kind of numbers were these? They were both
Perfect square.
perfect squares. So this is referred to as a difference of perfect squares. Remember hearing that phrase last year?
No. Yeah.
Okay, well, you need to commit it to memory right now because it's going to be very, very useful for the rest of your mathematical lives.
Different.
Okay? Difference of perfect squares. Because what we like to do with things that are like this, we like to factor. Okay? And remember this last year. We like to factor in things like that, right?
FOIL.
Okay, so factoring is the opposite of the inverse of FOILing. Okay? FOILing is multiplication. We're doing division. Okay? But so you're on the right track. They pair up with one another. When I have a difference of perfect squares, there was a really, really easy way of addressing those. Whatever that number was, y squared, you take the square root of it, and it goes there, and it goes there. Then you take this perfect square, take its square root, and it goes there, and there. And then you put a plus sign between one of them, and you put a minus sign between the other. Weird. Okay, so we get y plus 5 and y minus 5. Okay, and when we FOIL, so you're saying you're talking about FOILing, right? Well, FOIL is first times first is
Y squared.
y squared. So give me that. Outside times outside gives you
I get
negative 5y.
negative 5y.
What's inside times inside give you?
5y.
Positive 5y. What do those two do to one another?
Multiply.
Cancel out.
Cancel out. Negative 5, positive 5, they go away. Gives me 0y. That's why we don't see a y in here, 0y. But what's last times last then?
Negative 25.
Negative 25. So once I factor, I should be able to FOIL it to get back to what I started with. Just it's a kind of routine check to make sure that I haven't made a mistake yet. Okay. Now if I got two numbers that multiply together give me 0, one of those numbers is 0, or both of them are 0. So if I do that, does y equal negative 5 here? And y equal positive 5 there?
Yeah.
So it's an alternative way of factoring. Okay. Yesterday we did a problem. It's going to be useful for us to be able to do this. Like we had like x squared minus 5x plus 36 or something like that. I guess we can't do plus 36. That'd be minus 36. Maybe we did something like that. Okay. And we looked for two numbers that multiply together to give me 36 and add to give me 5, right?
6. 6
Okay.
and 6 is 36.
Yeah, I'll do that. Add to give me 5.
Negative 6 and a 1.
Okay.
Never mind.
But they don't go multiply together to give me 36, right?
Negative 6.
There's negative 9 and 4.
It is negative. In this case, it's going to be negative 9 and positive 4.
Probably.
Okay? So the idea of what we just did with y squared minus 25 was this. Y squared minus or plus, doesn't matter, 0y minus 25 equals 0. I put a plus on here to see logically, we don't want to like add 0 or subtract 0. It's kind of silly to do. It's kind of trivial to do that, right? Okay. But that's really what we're seeing here. One or two numbers that multiply together give me negative 25, but are additive inverses. They go to 0 when we add them together.
5 and negative 5.
5 and negative 5. So that's y plus 5, y negative 5, or y minus 5. And that's another way of viewing that. But what we learned is that with difference of perfect squares, no matter what they are, if I have, let's just go x squared minus 81, how's that going to go?
Positive and negative 6, 9.
Yep. X plus 9, x minus 9. What about x squared plus or minus, let's go minus 196.
14.
Yeah. X plus 14, x minus 14. Okay, and you factor those really quick if I know the square root of those numbers. Okay. Now here's what maybe you didn't talk about last year. If I go x squared minus 20, okay, and I want to factor that, okay,
Fraction.
we can still do this. We can still go x and x. Now what's the square root of that?
Fraction.
And well, it's not. It's a decimal. I can't write it as a fraction. I can write it as a decimal
That's not
because it's irrational. But basically, this number right here, another way of writing it is the square root of 196.
Yeah.
So just so I take square root of that, I take square root of that. So rack 20, rack 20. It's just real nice when those things are whole numbers that are perfect squares, because then in that set of binomials, I will have whole numbers instead of those radical 20s. But it's the same idea. Same approach of this problem. Last year, generically, you talked about it this way. If I have a squared minus b squared, that's a difference of perfect squares. It became a plus b times a minus b. And that's the generic format for factoring any set of perfect squares. Is that all right? Can I do something with pluses?
Yeah.
That's x squared plus 196.
Yeah.
Can I do this? Can I go x squared plus 196 and rewrite this as x? To be 14 again, right? But can I do pluses here? Can I create, maybe if I go plus plus,
Yeah.
okay? What's x times x? X squared. What's 14? Because now I got 4. I'm 4 of them all the time here. What's 14 times x? 14x. What's outside times outside? 14x, right? Plus 196. Okay. Does that get me back down to x squared plus 196? No. Okay. So these two things cannot both be plus signs. Does that make sense? Okay. Can they be minus signs?
No.
No, they both cannot be minus signs, because if they're both minus signs, okay, everything would be kind of the same, except for it would be negative 14x, so this would become negative 28x, not x squared plus 196, right? So then the idea is, well, let's alternate them. Okay, well, if I alternate them, okay, what's last times last going to give me? What kind of number is positive 14 times negative 14? Negative 196, not the positive we're looking for. Okay, so x squared. So we have rules for difference of perfect squares, but we don't have rules for sums of perfect squares. Does that make sense? Because they don't factor nicely like that. Okay, and you'll learn in algebra too. It's because we can't take really square roots of negative numbers. Okay, at least easily can't do it. All right, so that's some algebra stuff that hopefully we kind of recall maybe.